Okay, guys, so just to let you know, I've put together a reciprocal graphs video. I'm going to be overdubbing this because I just went through the entire thing. It's about an hour long, but my microphone did not record any of it. So I'm going to be playing through the video that I just recorded and trying to remember what I was saying at different points. So hopefully this works and best of luck. Okay, so in this video, we're covering reciprocal graphs, and I started with, hey, we got some function f of x, then the reciprocal will be y to the minus, well, it was 1 over f of x, right? That's what the reciprocal is. It's 1 over whatever it originally was. Okay, I think that's, yeah. I also mentioned the difference between the inverse notation and the actual reciprocal notation. So with inverse, that's how you write, what I've just wrote there is how you'd write the inverse of f of x, which looks very similar to the reciprocal, but to illustrate the difference, that is how we would write the reciprocal of f of x, right? So you just got the difference just to avoid confusion. Inverse of f of x and the reciprocal of f of x. I'm not sure what I was saying at this point. Okay, here, so whenever you're dealing with reciprocal graphs, vertical asymptotes are super common. They come up a lot. You can't have 0 on the denominator. Every time you do, you end up with a vertical asymptote. So, 1 over f of x, ultimately your vertical asymptotes, you're just going to be solving the equation. And here's an example here. So if you're trying to find the vertical asymptotes of this graph here, you would just take the denominator, x squared minus 2x minus 3, let it equal 0, solve that equation. It's a quadratic. You guys have done exercise 1C before. Again, I feel like I just drew something up there on the top. Okay, I'm just illustrating the point. If you got 0 on the bottom, it takes the whole thing off to infinity. Oh, okay, yeah, and I actually went through and explained that. So if you had, for example, 10 divided by 10, that's equal to 1. If you make that bottom number smaller, for example, in this case, 10 divided by 1 now, you get 10. You see what's happening to the solutions, right? As the denominator gets smaller and smaller, our solution gets larger and larger. And eventually you get to a point where the denominator gets so small, you end up with this infinitely large value. Can I speed it up a bit? I don't really know how. You don't know how sad I am just to spend an entire hour going through stuff and then now having to redo it. Fortunately, it's reciprocal graphs, right? So they're really fun. Okay, so I spend lots of time really explaining this concept. So you guys already know this, yeah? When the denominator is 0, you're going to get an infinitely large value. And, as it approaches 0, that's when it becomes infinitely large. All right, so if we're going to find the vertical asymptotes for this particular graph here, we're just solving this equation. It's a quadratic, so you can factorize this, you can complete the square, you can use quadratic formula. It doesn't make a difference, but hopefully I go ahead. No, I'm continuing to talk. Go ahead and solve the equation, sir. Do it. Oh, okay, I did make the mention of, so typically when you have an x on the bottom, you will have a vertical asymptote, but not always. This is an example that sort of just came to my head. If you had x squared plus 4, right, that's never going to be equal to 0, at least for the real number system. So if you had a graph where it was 1 over x squared plus 4, that would not have any vertical asymptotes. All right, here we go. So I ended up deciding to factorize. That's cool. ultimately giving us, okay, vertical asymptotes at 3 and -1. All right, congrats, we've got our vertical asymptotes for that graph. All right, next thing I believe we went on to was just looking at horizontal asymptotes. Yep, here we go. So to find your horizontal asymptotes, ultimately just finding the limiting value as x approaches infinity. So off to positive infinity or down to negative infinity. These aren't like always necessarily true horizontal asymptotes. Like sometimes it's possible in the middle value it actually passes through that 0 point. But anyway, so let's find the limiting value of this same function that we had previously. We're going to find the limiting function as x approaches infinity. So you sub infinity into the expression. You're just going to end up with, 1 over infinity squared minus 2 lots of infinity minus 3. Ultimately, the x squared is going to be the dominant term. It's going to be the term that's going to take control. So you're going to end up with 1 over ultimately infinity. Which, yes, I eventually wrote. Gosh. Do I always talk this long? Maybe I'm starting to feel your pain a little bit, guys. I even drew the infinity slope. Okay, so 1 over an infinitely large value is going to be 0. 0 from like the positive direction, right? Because infinity is positive. So 1 over a really infinitely large positive value will be 0, but it's coming from the positive end. So hopefully I'll put a plus there, like on the right hand side of that 0. Maybe not. And again, I'm not sure what I'd be talking about now other than just going on and finding the limiting value as x goes off to negative infinity. Okay, so here we go. We have, yep. So in this particular case, okay, yeah. So once you plug that negative infinity in, because it was an x squared, again, that's going to be the dominant term. You know that negative infinity, any negative value when squared will end up becoming a positive. Here I was illustrating if it was a negative infinity, it would be approaching 0 from the negative ends. But in this case, because of the squared, it ended up coming in from the positive ends. All right, so I'm not sure what I was doing with that arrow. I was maybe trying to illustrate the function, and I was probably saying something really important. So just sort of use your imagination there, guys. Okay, on to our first official example. We're just going to sketch this reciprocal function right here. We've actually been given the function. That will be the case of the first 2 examples we look at today. Okay, so here's our number plane. Whenever you're sketching reciprocals and you've been given the function like this, I always personally like to start with the vertical asymptotes. And no doubt that's what I would have done here. Okay, I'm illustrating that we've already found the vertical asymptotes for this particular function. They occurred at -1 and 3. So here we go. Let's get our vertical asymptotes in straight away. There's the one at 3. Look at that 3. That is shocking. And -1. All right, so once you have your vertical asymptotes in, you know the function as it approaches these vertical asymptotes from that side there, right? It's going to be heading off to positive infinity or alternatively negative infinity. And this is the same for any point that the function approaches a vertical asymptote, right? It's either going to be heading off to positive infinity or negative infinity. All right, so I believe if I remember, I started on the right-hand side for this function. No, I'm still talking about vertical asymptotes. Yeah. Okay, so I'm just illustrating, hey, it's going to be heading off to infinity as you approach a vertical asymptote. You may want to skip a bit if you need to. All right, the next point to look at will be our horizontal asymptotes. Like, what is happening to this function? So we know as we get to, okay, yeah, here we're looking at where, so we end up approaching 0 from the positive end. Okay, so I am looking at the far right-hand region. So we've got like 3 regions here. We're looking at this right-hand region to begin with. We know as x gets large, our function's going to be going down to 0 from the positive end, right? That's why I say it's going to be going down to 0, not up to 0. So our function's going to be going down to 0, and as it gets closer to the vertical asymptote, yeah, it's going to be going up to positive infinity. Now, if you're ever in any doubt about exactly what's happening, like you may know some of the information, but you're not 100% sure, you can always plug in some values. Actually, that's what I was talking about here. That's cool. So you could plug in the value 4 into the equation, just sub it in, get the value, maybe sub in the value 5, chuck in a couple different values. And it will give you a very clear picture of exactly what's happening if you're ever a little bit uncertain. All right, now we're going to go ahead and graph this first region, the far left-hand side. Again, we've got this vertical asymptote. We know we're going either up to positive infinity or down to negative infinity. So we combine that knowledge with our horizontal asymptote, which is, as x heads off to negative infinity, our graph approached 0 from the positive end. So that is there. Our function goes down to 0 from the positive end, which means then our vertical asymptote will be going up. The middle region, the section in between the 2 vertical asymptotes, are typically the harder regions to do. And like I'm saying, like you're going to be learning. Oh, okay. Here I was talking about, what about the possibility of it turning, and doing something weird like that. Typically, you only see those questions when it's been preempted. Like once we've completed calculus, you get those questions that ask you to find all the stationary points and determine their nature. They won't just give you a question like that just straight out of the blue. It'll be preempted by like some preliminary calculations that you do before they give that to you. Yeah, but anyway, finding the middle region of a function. So normally, using calculus, that's what you would do, right? You'd find, is there the turning point? Is it a max, a min, or a horizontal point of inflection? So I'm coughing now because I've now been talking for an hour and a half non-stop. But yeah. But like we don't have that yet, right? So how are we going to do it? Well, we can still graph it, right? So directly in between minus 1 and 3 is the point 1. And if we sub the value 1 into our graph, we end up getting negative a quarter. So we know directly in between our 2 vertical asymptotes, the function is at negative a quarter. And as we go either side to the vertical asymptotes, we know we're either going to be going up to positive infinity or down to negative infinity. And how to determine whether it's that option or the other? Ultimately, the easiest way for us to do it at this point is just to sub in a value. Like let x equal 2, sub that in, work out whether you're going up or down. I'm just trying to maybe contemplate. So I'm going to let x equal 2, plug it in. You're going to get the value 1 on negative 3, which tells us we've gone from negative a quarter, right in the middle. When we go across a little bit to the side, you get negative a third, right? It's a little bit further down. telling us that that's what's happening on that side of the midpoint. Now, what's going to be happening to the graph on the other side as it approaches the other vertical asymptote? And again, we've got two different options. It could do the same thing as what it just did. It could go down to that vertical asymptote, or it could do which is what I'm showing there. It could potentially do that, or it could be a horizontal point of inflection and actually turn and head on up. Hopefully, yeah, I show you an example of that too. All right, so there are two different options here. And again, the easiest way to do it is just to sub in a point. Let x equal 0, plug it in, and find out whether it's increasing or decreasing. Okay, I can fast forward it, and that's what it did. It continued to decrease, so it ended up looking like that. All right, on to the next one. Okay, so we're going to be sketching this one here. So yeah, we drew up the number plane. All right, so I started with the vertical asymptotes. Right, there you got x squared minus 4x. Let that whole thing equal 0. Solve to get your vertical asymptotes, which will occur at 0 and 4. So we have our vertical asymptotes in. That's really cool. Okay, yeah, blah, blah, blah. Okay, now onto the horizontal asymptotes. So what will be the limiting value as x approaches infinity? Sub-infinity into, x1 over x squared minus 4. And you end up with that x squared is going to be the dominant term, right? Infinity squared is obviously going to take over 4 lots of infinity. You end up with 1 over a positive infinity, which means 1 over infinitely large value means you're going down to 0 from the positive end. So here we can see we were going down to 0 from the positive end, which means, we're going up at that vertical asymptote there. I believe I go ahead, just like the last one, I sort of do this one the same way. I'll find the horizontal asymptote on the other end. And again, if you ended up with a negative infinity on the bottom, you'd be approaching 0 from the... You know what? It happens in a later example. So we'll just focus on this at the moment. All right, so what happens as x goes to negative infinity down the other end? And you end up with, negative infinity squared, right? Two negatives make a positive. So you're going to end up with 1 over positive infinity, meaning it's doing the exact same thing. All right, so you end up with that on the two outside edges. As far as us working out the middle section, all right, so again, I just subbed in a couple points. Went for the point right in the middle when x is equal to 2. So there is, so I subbed 2 into it. You get negative a quarter. Funnily enough, that's actually the exact same value as the middle point of the other one. Was there a gap of 4 with the other one as well? Yeah, negative 1 or 3. There was a gap of 4. No wonder there was similarities. Okay, and again, just sub in values either side of it. Sub in x equals 3 and the other one. Okay, so once you sub in the value x is equal to 2, just sub in the values either side of it, 3 and 1, and it will tell you whether it's going up or down. Okay, these next ones are actually super fun. We don't know anything. We haven't been given the equation. We just got this function y equals f of x. And they're asking us to sketch the reciprocal of it, right? 1 over f of x. Okay, so first things first, whenever f of x is equal to 0, 1 over 0 is going to be a vertical asymptote. So you look at the f of x function, right? We're going to look at that function there, and we're going to use that graph to create the reciprocal. Now, whenever that original f of x function is 0, you're going to end up with, for the reciprocal, a 0 on the bottom. You're going to end up with a vertical asymptote. So first things first, bam, there it is. I'm talking about it again. Let's get our vertical asymptotes in first. We have a vertical asymptote at well, ultimately the y-axis. Okay, so we've got this vertical asymptote here. Which side do I look at? I'm not sure whether I did the left-hand side or the right-hand side. Oh, okay. The next point I'm illustrating is this. This is another key concept with reciprocals. When you're finding the reciprocal of something, if something was originally a positive value, the reciprocal of it will also be positive, right? If you find the reciprocal of positive 2, it'll be a positive a half. So when you look at the positive region of f of x, like that's positive, the reciprocal will also be positive values. And likewise, if you had a negative value for f of x, if you're below the x-axis, here we've got -2, the reciprocal of it will be -2. So the signs of the actual values won't change. Positives of f of x, the reciprocal will remain positive, and negative for f of x, the reciprocal of it will remain negative. So we can work out vertical asymptotes, nice and easy, and we also know whether it's going to be above or below the x-axis. The next point that we know is as f of x heads off to positive infinity, which is what I'm trying to show those arrows there, as f of x goes off to positive infinity, the reciprocal will be 1 over infinity, right? Which we know is 0, is heading off to 0. And this was a positive infinity, so you're heading down to 0 from the positive end. So that is how combining that concept of we're heading down to 0 and we've got a vertical asymptote there, you're going to end up with that arm, kind of looking like the start of a hyperbola graph, to be honest. That would be the other end of the hyperbola graph. So obviously I was talking about that then as well, but that's not actually what we end up with here. Looking at this other side of f of x, right, we got positive values, right? It's above the x-axis. That means our reciprocal also will need to be positive in its sign. So it's going to be up here somewhere. And you can see that, it's heading off to positive infinity over there. So the reciprocal on the right-hand side would be 1 over positive infinity. In other words, 0 from the positive end, right? 1 over an infinitely large value is heading towards 0. So we're heading towards 0, and we've got that vertical asymptote. So linking up those two ideas, you end up with the completed graph. Notice how the reciprocal, when f of x was positive, our reciprocal was also positive. Oh, and I've written down exactly what that was. That was y equals 1 on f of x. All right, hopefully I'll go on to the next one now. Okay, I'm just illustrating that. Oh, okay, no, this is super crucial here. Okay, the other point I wanted to illustrate at this point was when f of x is going up, so look over here in red, where at f of x on the left-hand side is going up there. It's got a positive gradient. The reciprocal, during that same corresponding portion, is going down. It'll have negative gradient. Reciprocal will have opposite signs in gradient. And if you look at that section there on the left-hand side of f of x, you have a negative gradient there. From left to right, that graph was going down. And then when you go and look at the corresponding section of the reciprocal, it's going up. So yes, positive values will remain positive, negatives will remain negatives, but the signs will change. That's going to be a very crucial skill and concept for us with working out some of these harder graphs that are coming up. We didn't need it for this first one, but this first one is very basic. Okay, all right, this next one. So we're going to sketch the reciprocal of this one here. So again, first step always, let's work out a vertical asymptote. We don't know the value of it, so you just approximate where you think that approximately is. When f of x is 0, the reciprocal will have a vertical asymptote there. So hopefully, yep, there we go. We got our vertical asymptote in. Yeah, I remember rubbing that out just to make it, as if I do anything neat. But I was attempting at that point. All right, so we got our vertical asymptote. You'd look at like the function. Do I do left or right hand side first? It's hard for me to say. Oh yeah, I'm doing the right hand side. So f of x is approaching infinity, which means the reciprocal is heading down to 0. So combining vertical asymptote and that horizontal asymptote, we end up with that. And I'm just re-illustrating, that horizontal asymptote, right? F of x is approaching a positive infinity. So you end up with a 0 from the positive end. If x was a negative infinity, if f of x was going down to negative infinity, 1 over an infinitely large value would still be 0, but it would be coming from the negative end, which is what I was illustrating there. Looking at this other side, you can see, hey, f of x is again heading off to positive infinity, meaning the reciprocal is going to be heading down to 0 from the positive end. And that's that one done. Do I talk about the signs at all, just to re-illustrate? When f of x is negative, when it's going down, the reciprocal is going up. Let x equal 0. Oh, okay, I'm just finding the y-intercept. But that cannot be found without the graph. So, that line did actually have a y-intercept, but it was unknown to us without some more information. I'm now just sitting here bored, wondering what it was I was talking about. I'm sure they were really good points, guys. Oh, okay, yeah, I actually do look at... Okay, so if you look at that left-hand region where I just highlighted red, it had a negative gradient. It was sloping down the whole way. And so... I don't, and here the green section has a positive gradient, it's going upwards, and if you look at that section of the reciprocal, it's going down. So the gradients, the slopes will be opposite. Alright, let's get straight into the next one. Okay, so here's our next one. We have at 2 points, f of x is 0, which means we're going to have 2 vertical asymptotes. Oh, here we go. I went to orange. You got to listen to your audience. Know what they want. They want orange. Okay, so this one here has 2 vertical asymptotes because there's 2 points where f of x was 0. So we get our vertical asymptotes in first. I've left like almost no room for that final region. I don't know what I was thinking. And let's see if I start working left to right or whether I keep sort of doing it in mixed order. Let's find out. Okay, so for this one here, again, when sketching these ones here, you get your vertical asymptotes in, you can work out, like if I was to look at the left-hand side first, which I actually did do. You can see the graph is going down to negative infinity, which means the reciprocal is going to be approaching 0 from the negative end. There I can see it there, right? 1 over negative infinity is approaching 0, but from the negative end. And if you combine that with your vertical asymptote, you can guess pretty accurately what this thing is going to look like here. And the other point to illustrate is, hey, look, during this section that I've just highlighted orange, it's negative, right? It's got negative values, meaning our function can't turn and go back up, right? If f of x is negative, the reciprocal will also be negative. Just like when we saw, that like, okay, and now I'm looking at the slope, it's a positive gradient, right? So from left to right, it's going upwards, which means the reciprocal will need to be going downwards. So the actual values stay the same. Negative values, we're down on the negative side of the graph. We're below the x-axis in both cases, which is what happens. But the reciprocal, the actual gradient will be reversed. Positive gradient, the reciprocal, we've got a negative gradient there. Again, you probably already knew what the graph was going to be doing in that section, just from the vertical asymptote and the horizontal asymptote. But, looking at those signs can give you extra information. Now, sorting out the middle section, that is no doubt the trickiest part. But again, we've sort of got everything we need to do this now. If we look at this middle region, right, we've got this situation where if you look at, okay, you're heading up to that turning point, and f of x is increasing. It's getting larger, which means our particular reciprocal will need to be decreasing from that point right down to that middle value. And I'm talking about the middle value at this point. I forget exactly what I was saying, but I was talking something about the middle value. And, it's so the reciprocal will be f of x was increasing right up to that middle point, which means the reciprocal will need to be decreasing, right? So we know with a vertical asymptote, you're either coming down from positive infinity or up from negative infinity. We know our reciprocal needs to be decreasing because f of x was increasing. So decreasing, we know we had to be coming down from infinity. Where to turn the point when you don't know the value? Again, I've just randomly put in the value 1 there, but that wasn't in the original question. I was just talking about, we don't know the value of that turning point. So we don't know where it actually turns. Where I've turned it here is definitely not right. I was illustrating the point. In that middle section, they're all positive values. That means the reciprocal can't go down into the negatives. So I don't know exactly where our reciprocal will turn, but it needs to turn somewhere up in the positive side of it. And it will be the reciprocal of whatever that value was. And here I've got the value 1 written there, which means it would be turning at, 1 over 1, which is 1. Anyway, what does it do from this point? It needs to head off to that vertical asymptote, either up or down. But when you look at the signs, and right on that point, you can see f of x is not increasing or decreasing, right? It's like got a 0 gradient. Our reciprocal will also have a 0 gradient at that point. So the reciprocal will always have the opposite. When it's increasing, the reciprocal will decrease. When it's decreasing, which is what's happening here now, when f of x is decreasing, I'll put those negatives, the reciprocal will need to be increasing. And so that's why we knew it needed to increase back up. Looking at the final region, you got these negative values. F of x is continuing to decrease, which means the reciprocal will need to be increasing. So we've got to increase, as in our slope needs to go up. We've got negative values for f of x, so we know we need to be below the axis. So we've got to be below the axis. It needs to be increasing. You've got your vertical asymptote here. You probably already know. You could, if you really wanted to, you could find that horizontal asymptote 1 over, I'm doing it here. 1 over negative infinity ends up giving you a 0 from the negative end. So it's approaching 0 from the negative end, and so you end up with that there. Did I put an arrow on the bottom? Well, I didn't. Okay, next one. We want to sketch this. Okay, so we've got this parabola here. It has 2 different x-intercepts, and we know the reciprocal, whenever x is 0, the reciprocal is going to end up with vertical asymptotes. So there's our 2 vertical asymptotes. at -1 and 4. They've actually given us some values for this one, so this is really nice. Look at that 4. Yeah, I should have rubbed it out. That was horrendous. All right. So we've got our 3 regions. Finding the first region. Hopefully I do the left-hand side first. I'm just going to start talking about that. Right, so it's heading off to positive infinity. So, yeah, we're going to be heading down to 0 from the positive end. You got that vertical asymptote there. You already know what it's going to do, right? It's going to be heading up to that vertical asymptote. But if you really wanted to, talk about it, hey, look, f of x has negative gradients through that region. It's going down, which means our reciprocal would need to be going up. But we already knew that anyway. All right, this middle section, so the trickier but probably the funnest part, the region between the 2 vertical asymptotes. So, from -1 up until the middle point, what's directly in between -1 and 4? So like 1.5. It had a negative gradient. It was going down, which means the reciprocal will need to be going up. We have no means of determining that y-intercept. So, I'm talking about what's going to be our turning point. See here, we actually knew -3 was the bottom point. And so when we were doing our reciprocal, what's 1 over -3? It's -1/3. So we know it actually goes up to that point there, -1/3. So f of x was decreasing. It hit that point there where it stopped, and then it started increasing. Our reciprocal will need to do the opposite of increasing, which is decreasing, which is why I started decreasing it. Took it towards that vertical asymptote, which you're probably getting pretty familiar with doing. And looking at the final section, you got the vertical asymptote. The graph is heading off to positive infinity. So 1 over infinity is going to give us a 0 from the positive end. So, okay, all right, I started to look at the signs first. I think I was just loving them. So f of x has a positive gradient, which means the reciprocal will need to have a negative gradient. It needs to be decreasing through this whole particular point here. So it obviously can't be coming up from negative infinity. It has to be coming down from positive infinity. And here it is, I'm drawing that downwards part. It has to be coming from there. And yeah, if you look at the horizontal asymptote, f of x heads off to positive infinity, so 1 over infinity is 0 from the positive end. All right, here we go, polynomial. This was the first really fun one. So we've just been given this graph, right? We've actually been given some information about it. Like we know the x-intercepts, and we've been given the values of the 2 turning points. And just from this alone, we're going to be, look at that, vertical asymptote. Yeah, that's right, sir. You fix that. So just from this graph, we're going to be sketching the reciprocal. So first things first, starting with vertical asymptotes, we have 3 of them here. So we actually end up with 4 different regions to this reciprocal graph. The first region, here we can see the graph is heading down to negative infinity. Let's get straight into it. Come on. Okay, all right. So this is our orange section. So f of x was heading down to negative infinity. So 1 over negative infinity gives you a 0 from the negative end. So we know that as x goes across to the left, we're going to be going up to 0, right? We're going to be approaching 0 from the negative end. Combine that with the vertical asymptote. There you go. You've got the first region done. Not too bad. you know, if you really wanted to look at gradients, everything links up. You know, that orange region, you had negative values. The reciprocal also was below the x-axis. It also had negative values. And if you look at the slope, f of x had positive gradients. From left to right, it was going up. And our reciprocal, you can see from left to right, it's going down. Everything works out. And I actually decided to put them in. So you had positive gradients through that point. The reciprocal had the negative gradients. All right, next region, so let's go. All right, so this next region, which I've made green, it's between the next two vertical intercepts at -3 and 2. So in this particular case, you know, you can see, hey, we know the function's going to be you know, as we get close to the vertical intercepts, it's going to be approaching either positive or negative infinity. Directly in the middle, so what is directly between -3 and 2? That's like -1/2. So directly in between those 2 points, we've got a turning point. It had the value 2, so the reciprocal of it will be 1/2, right? And so that's what I've done there. At -1/2, we actually have the y value will be 1/2, right? It was the reciprocal of 2. And I'm drawing an arrow to that point because I'm talking about that point right there. Okay, on this left-hand side, f of x was increasing. It had a positive gradient. So our reciprocal will need to have a negative gradient. It needs to be decreasing, which is why it's coming down to that point. On the other side of that point, we had negative gradients for f of x, which means the reciprocal will need to have positive gradients. It needs to be increasing. So we end up with something that looks like that. All right, by the way, just to let you know, you actually would not be able to determine that y-intercept there. We know it's above 1/2. It's a little bit more than 1/2, but we don't know exactly what it is. Not without extra information. Okay, the next region. Okay, this is our purple region. So the next part, we just do it exactly the same way we did the last region. That middle point is at -3, right? That turning point where it shifted. So the reciprocal of that is going to be -1/3. So that's, you know, the point directly between 2 and 5, which is 3.5. You can see the left-hand side, f of x was decreasing. So our reciprocal is going to be increasing from left to right. We had to increase, which means we had to come from negative infinity because it had to increase. And then f of x had positive values there. So our reciprocal had to have negative values. It went back down to negative infinity as you approach to that next vertical asymptote. And the final region, f of x heads off to positive infinity, which means this one here is going to be heading down to 0 from the positive end. And bang! Not too bad. Like I'm saying, it looks pretty cool too. It looks like a hard question, but they're really not too bad, to be honest. All right, I'm going to skip ahead a bit. Okay, this next one here. Oh, okay, yeah. So I'll pause it just for a quick sec. This one here is a graph of like what looks like a hyperbola, if you have a look. I actually drew the equation down the bottom here of what I suspect the formula would approximately look like. I did this because a little bit of a trick. You know, you find the reciprocal of this. You know, you find the reciprocal of 1/x plus x minus 3. You flip that, right? You just end up with x minus 3, right? It looks like, oh boy. It looks like this one here is just going to be a straight line. Yeah, keep going. Sorry, guys. I'll get back to it. Okay, I'm going to leave it there, guys. All right, I'll talk to you guys next time. I've lost the last 2 questions.